Hello, and welcome to the HydraFiber Culture Clinic presentation. I'm Kristen McGuigan, a technical account rep for HydraFiber, and have the pleasure of delivering this content. The information we have prepared for you is a collaborative effort between our sales and our technical teams. We have given careful consideration of the content to be included, as we want this to be as informative and useful as possible for the new grower to HydraFiber. So let's begin. Today's presentation will be presented in two parts. Part one is an overview of what HydraFiber is and how it affects your growing media. The second part will outline the best watering practices for a grower in a HydraFiber blend. Well, what is HydraFiber? Let's start right there. HydraFiber is a wood fiber material which is produced in a factory. We start with reclaimed or recycled wood chips that are a byproduct from the timber industry that we receive from a day's drive to our factory in beautiful Conover, North Carolina. These chips are repurposed through a heat and pressure process to be refined into a viable wood fiber material. The intense heat the chips are subjected to during the refining process results in the end product being sterile. This is important because it eliminates the risk of spreading any unwanted pathogens. We use only one species of wood to make this product, and that's southern yellow pine, also called loblolly pine. The thermally refined process we use is unique to profile products, and one of the benefits of using this method is it creates a lot of surface area on the fibers, or a lot of places where water can enter into the fiber. This is very important, as we'll see later when we look at water management. What the fibers also do is create airspace in the soil for easier rooting. When you touch the fiber, you'll notice they are very spongy to the touch. The chart on this slide shows the characteristics of the 5 different HydraFiber Ultra products offered to growers. Taking a look at the top colorful bar on the chart, you see the HydraFiber products listed from the 065 WB on the far left to the 510 WB on the far right. Each one of these columns represent a unique grade of fibers we offer, and growers select their grade for production based on things like the crops they're growing, the geographic location that they're in, the time of year, the crops they're growing, the container size. For example, you'll see the 065 WB or wood blend is listed for use in propagation. And as you can also see, it has more water holding capacity and less air pore space than the 2 products listed on the far right. The 365 and the 510 WB are generally used more by nursery and perennial growers, since the 2 products offer the greatest amount of air space, which is sought after in production of those crops. In general, the majority of bedding plant producers are using the 160 WB listed in the yellow column on the slide. The 160 provides a healthy balance of air porosity and water holding capacity at the same time. Okay, we promise we won't get too chart heavy in this presentation, but this chart helps support the slide we just looked at. You'll see the 5 HydraFiber Ultra products listed on the left in colorful bars. And what's important is their chemical characteristics are all the same, meaning a bale of 065 WB has the same pH and EC values as the 510 bale. The only difference between the 5 products is the fiber size. Some are very fine, others are coarse, with a few in the middle so you can better tailor to your plant's unique needs. One of the most commonly asked questions about growing in a HydraFiber blend is, how will using HydraFiber in my soil affect my feed program? Along with a follow-up question about nitrogen drawdown. The bullets on this slide and the next slide that we are going to look at are from experience of our grower customers, along with extensive data testing and collection work done by our R&D group. Taking a look at the first bullet point, this is for growers who currently add lime to their soil blend during mixing. We have found in general that by replacing 10% of peat in their soil blend with HydraFiber results in a 10% reduction of the lime needed to achieve the same desired pH. Tests should be run on small batch scale to ensure the proper pH is achieved, and all blending equipment should be calibrated on a routine basis to be sure you are getting a consistently uniform mix. Looking at the second bullet, as more HydraFiber is added to the mix replacing peat moss, there's a higher risk of pH drop from acidic feeds. This is in part because peat has a strong cation exchange capacity, or CEC, meaning it has great buffering capacity and can store nutrients the plant can use later. HydraFiber, on the other hand, does not work in this way and will not buffer the soil in the same way that peat does. This highlights the importance of following a good soil testing program and, again, having your equipment calibrated regularly. The last two bullet points are a summary of what we find in general with growers who have switched from a peat perlite blend to a peat HydraFiber blend, or simply just replacing the perlite with HydraFiber. We find that growers do not use more feed with a HydraFiber blend. There is not a need to feed the wood, and this is due to the way HydraFiber is manufactured. In the end, using HydraFiber material in your soil mix provides a more stable blend compared to most raw materials. Like the last slide, these points have been verified by many of the growers currently using HydraFiber in their soil program. They find that in general, they are not making adjustments to their feed program. In most cases, they are using the same parts per million and the same frequency in their feeding as they were before adding HydraFiber to their blend. There is an exception, however, and in cooler months, some, and especially northern growers, increase their feed rates by about 25% because they're irrigating less due to these dark conditions. Once the day length starts to increase and the outdoor temperatures warm slightly, normal feeding programs are typically followed. Regarding fungicide, insecticide, and PGR applications, again, growers are not adjusting the rates they used before switching to HydraFiber in their blend. This is true with growers using paclobutrazol products as a PGR. This chemical does have a tendency to get tied up in wood substrates. However, in extensive grower production and in collaborative testing efforts with Michigan State University, we have not seen HydraFiber blends show a need for more active ingredient to achieve the desired effect. In short, we suggest following the label rates you've been using for fungicide, insecticide, and PGRs as you begin to work with your new blend. You might be wondering, what is it about this product that has made it so popular and so quickly? Well, we've touched on some of this already, but let's dive deeper. As you'll see with the product, HydraFiber is very spongy in nature, and this sponginess allows for more airspace in the soil, making the job of the plant to put down roots much easier. The fibers knit together, and in between the other soil particles like peat moss or coir in the blend, the fibers become like a wick in the soil for water to be easily transferred from the top of the soil and around those other particles in the blend. What the fibers are doing is taking the available water in the container and wick it down lower in the plant's container. This does a couple things. It creates a drier soil surface, and it helps the roots dive deeper into the container faster. The drier soil surface is great because it typically less algae forms, and it also reduces pesky fungus gnat populations. Direct stub cuttings are gaining in popularity with growers, and we find that HydraFiber soil blends perform very well in this application due to the fiber's ability to wick that water lower in the container and ultimately help driving those roots down. Another reason for HydraFiber's adaptation is due to it being available on demand, made in the USA, and that it's a reliably consistent material. Most other raw materials vary from load to load, but each bale of HydraFiber you receive will be within the stated pH and EC range. We find that most grower customers or growers in the trialing stage start with a 30% inclusion rate, with the 70% of the balance of the blend being other raw materials, most commonly peat moss. After trialing or growing in a 70% peat, 30% HydraFiber blend, growers develop a comfort and look to increase their inclusion rates to a 40 and a 50% inclusion. Some growers will use different inclusion rates based on their container size. For example, we see several growers using 40 to 50% HydraFiber in their large container programs. This results in a final container with a strong root system and a lighter overall weight due to the spongy nature of HydraFiber, as it will lighten the weight of the overall container. The next few slides we're going to look at here are a picture show. These images are captured from the field and show a wide range of crops being produced in HydraFiber blend. In this slide here, you see some different bedding plants produced, and you see a petunia here at 50% HydraFiber Ultra with the 065 fiber. Over here, we have a geranium and 50% HydraFiber. A few perennials that have been documented growing in HydraFiber. Here you see a nice blend of peat, bark, and HydraFiber in this blend for the coreopsis on the far right. Some specialty crops grown in HydraFiber, Cyclamen, for those of you who are growing Cyclamen, you know that's a pretty long-term crop and really no issues growing in HydraFiber blend. Edible crops are on the rise with consumers and with growers, and again, no troubles growing in HydraFiber blend. And here are some ornamental shrubs being grown in HydraFiber. This is an interesting slide, and this is work done by Dr. Glenn Fain at the Auburn University in Auburn, Alabama. What we see here is a trial of inclusion rates, and as you look at the pictures, you can see the results. All these plants were grown in the same greenhouse, under the same conditions, same time of year. The only thing that's different is the inclusion rate. So we take a look at the slide, and they're all set up the same. You've got the control on the left, and the HydraFiber inclusion rate treatment on the right. So we talked earlier about 70-30 being kind of the introductory rate that growers are using for HydraFiber blend. In the picture, as we move to the right, you see a 40%, so 60% peat with 40% HydraFiber. Moving down to the bottom left, we have a control again on the right with a 50% peat and 50% HydraFiber. And then the last picture here, it's tipping that balance over to 40% peat with 60% HydraFiber. All these plants are very, very saleable and looking great. Okay, we're going to switch gears now from looking at the product and the application of it to watering. Here are some of the key benefits that we just reviewed. Irrigating and HydraFiber blend. Most growing potting mixes, especially for bedding plant growers, have a base blend of either peat moss or coir. This graphic here helps show these materials, how they react when water is applied to them. In the case of peat moss, peat has a waxy cuticle which repels or pushes water away, not letting it easily be absorbed. In the case of the coir on the far right, coir gathers and is stored, and the coir stores all the water that it could possibly hold. Now, remember when we first started looking at HydraFiber in this presentation as a product and it being thermally refined? That process it creates a lot of surface area on the fiber, and it lets the fiber take in the water wherever it's available, like coir, but the fibers do not trap the water. Instead, those wicking fibers move the water lower in the container so that a sufficient water will always be available for the plant's roots when they need it. If the soil blend you are currently using is a peat perlite mix, sometimes called a peat light mix, this chart is a good reminder of how it visually looks and also reacts to one that you're familiar with, and also how you'll find it differently growing in a HydraFiber blend. One of the main differences you'll see is a drier surface area with HydraFiber due to the fibers moving water from the surface to the bottom of the container. This results in HydraFiber plants being heavier by weight when picked up compared to a peat perlite mix. When the irrigation is managed appropriately, you should also notice that plants root in faster to a HydraFiber blend. This is HydraFiber working more efficiently in moving the water in the container, making the uptake by plants easier to achieve. The initial moisture of your soil blend is very important. This is something we will work closely with your team to make sure we have it dialed in before the containers are ever moved to the greenhouse. In brief, the initial soil should be wet enough that it holds a ball when squeezed in your hand, yet not so wet that excess water drips from it. When you start watering in the new blend, the initial first watering is always very important. And in this case, it might be different management water practice for some, but it's important not to completely saturate the pot right after transplant. Or differently said, avoid irrigating to leach until the roots start to reach the bottom of the container. However, in those first few irrigations, You'll need to keep in mind to water enough so that the plugger cutting and the soil around it stays moist. We have found when containers are kept too wet, increased algae appears, and it can also slow or stunt your plant growth. Here we see some key indicators while watering in the greenhouse. Be sure to pick up those pots as you make a decision for that day's watering needs. In general, you'll notice that HydraFiber blends will need about 1/3 less water than containers in a peak perlite blend. Keep a close eye on the visual cues your plants are giving to you. You'll find it especially helpful early on to lift those pots out of their containers and look at the root development. The pictures here are what you'll want to be looking at for your own crops, and the surface drying your plants will start showing. HydraFiber blends will visually look different than other mixes. If you have been using or are familiar with the 5 levels of soil moisture guidelines, these pictures here can help be a good visual aid for the soil color shade associated with the plant's moisture needs. As we've been looking at during the presentation, plants grown in a HydraFiber blend will have a drier looking surface, and the former visual cues you may have used as a grower need to be adjusted. In this slide, all these plants were grown in a 70-30 HydraFiber blend, 70P, 30% HydraFiber. Here we see the plant on the far left at a level 5, meaning the soil ball is completely saturated and won't require watering. Moving to the right, the soil color starts to look lighter in color as we move with each picture. Depending on the crop you're growing, but in general, you'll want to plan on watering when the plant reaches about the 2 to 3 stage. Remember, the weight of the container will also help determine the plant's need for watering, so pick up those pots to verify what you're seeing. Here we have some of the main differences to be looking for with a HydraFiber blend. Remember, a dry soil surface does not necessarily mean watering is needed that day. Pick up those pots, check out the root zone to make sure. We do respect that changing your soil media is a major change for any growing operation, and it will take some time growing in your new media to feel comfortable with it. Keep in mind the techniques we looked at in this presentation, and it will help make the transition smoother. Please know there is a full team of passionate industry people who work on the HydraFiber team, and we are here to support your transition because we want to see you continue to produce premium looking, healthy plants. We look forward to working with you and sincerely thank you for your business.